7.4 Properties of Special Parallelograms. So far in 7.2 and 7.3 we've been looking at parallelograms, but now we're going to take a look at more parallelograms, just special parallelograms. So the first one we're going to take a look at is a rhombus. Now a rhombus is a parallelogram with, okay, now starting out, this is a parallelogram. So do you remember that in a parallelogram, opposite angles are congruent? Still true. Opposite sides are congruent? Still true. Diagonals bisect each other? Still true. Everything that was true about a parallelogram is still true about a rhombus, a rectangle, and a square. Keep that in mind. So a rhombus is a parallelogram with 4 congruent sides. So I like to think of a rhombus as a square that got hit by a bus. So picture that, a square got hit by a bus, so he's slanted. A rectangle is a parallelogram with 4 right angles. So he is a very straight parallelogram. And then a square is a parallelogram with 4 right angles and 4 congruent sides. So if you think about it, it's like the rhombus and the rectangle got together and had a baby. Their baby would be the square. Now, here are the corollaries. It kind of says what I said. Take a moment, pause the video, read through these. I'm not going to do it for you, but it goes over once again your rhombus, your rectangle, and your square. Now this chart, I really like this chart because it helps us to start answer the questions of sometimes, always, or never, which we're going to actually do in example 1. But just as an example, okay, inside this box, we have all parallelograms. So is a rectangle a parallelogram? Yes. And the answer there would be always, because it's always in this box. Now, is a rectangle a parallelogram? Yes, always. Is a parallelogram a rectangle? And the answer there would be sometimes. A parallelogram is a rectangle when it has 4 right angles. Okay, so if you're kind of like going smaller, parallelogram to rectangle, that's a sometimes. If you're going bigger, rectangle to parallelogram, that's an always. And then there's a never. We'll cross that bridge later. But I really, really like this chart. And then remember I said like the rhombus and the rectangle got together and had a baby, which is a square. So all the characteristics of a square also belong to rectangles and rhombuses. Now, we already had some theorems. We know that in a parallelogram, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. But there's more. So, in a rhombus, okay, first of all, we already know that the diagonals are going to bisect each other. So I know this is congruent to this, and I know this is congruent to this. But if it's a rhombus, I also know diagonals are perpendicular. Okay, which means not only are they going to bisect each other like in a parallelogram, they're going to hit each other at a 90-degree angle. And that's in your rhombus. Now, also in your rhombus is the opposite angles theorem. So the diagonals bisect opposite angles. Now, what I mean by that is, do you notice these little tick marks and these little tick marks. They cut this thing in half. So let's say I said angle B is 50 degrees. Well, then I know that angle D is 50 degrees. But then the diagonal goes through here, and because it's a rhombus, okay, rhombus, it's going to cut it in half. So then I know that this guy is 25 and this guy is 25. Then I know this guy is 25 and I know this guy is 25. So the diagonal cuts the opposite angles in half. Now, moving on just a little bit on this guy, do we remember that in a parallelogram, consecutive angles are supplementary? So if this is 50, what does this have to be? And the answer there would be 130, which means then this has to be 130. And then if I have a diagonal that cuts through that, well, it cuts it in half. So if I take 130 and cut it in half, then I know this is 65, this is 65, this is 65, and this is 65. And that's by the rhombus opposite angles theorem. One more. Rectangle. Okay, rectangle diagonals theorem. So first of all, if it's a rectangle, we already know that the diagonals cut each other in half. So this is congruent to this, and then this is congruent to this. But if it's a rectangle, the diagonals are congruent, meaning that the length from D to B is the same length as from A to C. They are the same length. Versus if you look at the rhombus up here, notice that like DB is longer than AC. In the rectangle, because he's straight, these guys are congruent, which means then if they're cut in half, all four of these are the same length. Example 1. For any rhombus, QRST, decide whether the statement is always, never, or sometimes true. Explain. First of all, QRST, I'm going to draw, and it specifically says rhombus. I'm going to draw a rhombus. So it's a parallelogram with 4 congruent sides. So remember, that's like a square that got hit by a bus. And I'm going to say Q, R, S, T. Letter A. Angle Q is congruent to angle S. Well, that's always. And the reason I'm allowed to say that is because a rhombus is a parallelogram, and that's the parallelogram opposite angles theorem. Meaning opposite angles in a parallelogram are always congruent. Letter B. Angle Q is congruent to angle R. What do we think? I'm going to say sometimes. Okay. In my particular picture, they're not. Q is obtuse and R is acute. But what if I drew my rhombus as a straighter rhombus? All a rhombus has to be is a parallelogram with 4 congruent sides. Well, there's a rhombus with 4 congruent sides, and now what do I notice about those angles? This is actually a square. Well, guess what, people? A square is a rhombus. So sometimes, if the rhombus is a square, then they're all 90, so then they're congruent. Letter C. Rhombus QRST is a parallelogram. Always. It's the definition of a rhombus. Remember, the definition of a rhombus starts with a parallelogram with 4 congruent sides. It's always a parallelogram. It's the definition. And then letter D, rhombus QRST is a square. Sometimes. And that's when it has 4 right angles. then it would be a square.